Good afternoon, everyone. Am I audible?
Yes, ma'am.
Okay. So, hello, everyone. Dear authors and invited guests, welcome to Technical Session 90. I am Rajnandini Patil, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication. The 10th edition of the conference is being organized in hybrid mode. The physical event is held today in Pune, and the virtual event is being held through Zoom from 19 to 21st January 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and the 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce all to the chair for this session. That's the Dr. Sheetal Nayan Girme. So, the Dr. Shiltan Nayar Girme is an assistant professor in the Computer Engineering Department of SCTR's Pune Institute of Computer Technology. She is researcher in blockchain and distributed systems security with research interests spanning blockchain technologies, distributed system security, and algorithm and methods for coordinated election. Welcome to the session, ma'am.
Thank you. Thank you so much for nice introduction.
Okay, thank you, ma'am. Now let's start with the first research paper. For this, I would like to call Sri Tarun Raju for paper title A Blockchain-Based Energy Trading with Reinforcement Learned Dynamic Pricing and Automated Market Clearing Mechanism. I
Uh,
kindly request the presenter to start with the presentation.
uh, Hello, am I audible?
Yeah,
Yeah, let me
Yes,
share
you're
my screen.
audible.
Yeah. Let me share my screen.
Yes.
So is my PPT visible to everyone?
no, it's flickering. It's flickering.
Hello.
No, it's not visible.
Oh, okay. One second. Uh, uh, yeah. Is it now? Hello.
No, it's still flickering.
Yeah. Can you see it now? Hello.
No, Tarun, it's not
Hello.
visible.
Yeah.
Hello?
Can I send? Hello. Can I send my PPT to the presenter so
Yes?
that like uh,
Yes. Yeah, you can send the PPT in the chat. I will share it on your behalf.
oh, okay, thanks. Uh, yeah, it's sent.
Yeah, I will. Tarun, can you share me in the PDF format as I'm not able to open in PPTX? Maybe there's some issue in the PPT. I
Yeah.
will.
1 minute.
Yes.
Just a request if someone else can present in the meanwhile and then next he can present.
Yes,
Yeah, we
yes.
can, Rajnandani, you can wait for next 1 minute. Otherwise, you can shift to move on to the next presentation.
Yes, ma'am. Tarun, when your problem is solved, you can just message me in the chat and we will go on then. For now, let's move on to another presenter.
Yeah, sure.
So for next presentation, I would like to call Vishwa Modi for the paper title Board I Intelligent CBC Component Detection System. I kindly request the presenter to start with the presentation.
Okay, I will share my screen. Thank you.
Yes.
Is this visible? Hello,
Yes, it's
am I
visible.
audible?
Yes,
Yes,
it's
ma'am, it's
visible,
visible.
and you make it full screen. Go
Okay,
to presenter mode,
yep,
and then you can start.
yes, done. So, good afternoon, everyone. Present here. I am Vishwa Modi, currently pursuing MTech in Robotics and AI from Nirma University. Today, I am going to present a work titled BODI, Intelligent SBC Component Detection System. And this work is co-authored with Dhaval Shah and Viranchi Pandya from Nirma University. So, this is the agenda of our work, and I will start with the introduction. In the recent years, the hands-on learning in electronics has increased due to use of development boards like Arduino, Node MCU, Raspberry Pi. However, students often face difficulty in identifying small and closely packed components. And this is problem is not just limited to student alone, but it is also faced by trainees and beginners in industrial environment. Also, manual identification using datasheets or online references is time consuming and it often interrupt the learning or development process. So, to address this challenge, we have proposed an AI-based solution that can visually identify and label the electronic component directly from live camera feed. So by using embedded AI and computer vision, our system detects and labels component in real time using Raspberry Pi 5 and trained YOLO model, that is a YOLO model V8, and makes practical work easier. Next is a problem statement. Uh, despite the growing use of development board in education and industries, most beginners still struggle due to lack of effective interactive tools that are made for identifying the components on development board. Even the existing solution mainly focus on industrial automation or inspection and task, and they are not really designed for educational use. So as a result, user often face difficulty and often depends on manuals or online images or error and trial method, which can slow down the learning process. Also, there is also a lack of real-time on-device system that can instantly identify the component without relying on cloud services. So this highlights the need of low-cost, portable, and intelligent solution that can support component-level learning in both educational and industrial environment. Next is objective of the work. The primary objective of this work is to design a real-time component detection system using embedded artificial intelligence. Here, we aim to train a custom object detection model that is capable of identifying various electronic components present on the board. Another key objective means another two key objectives are first is to deploy the train model on the Raspberry Pi, enabling
Just
the
a minute,
efficient.
just a minute.
Okay.
Vishwa,
Yeah.
can you hear me?
Yes.
I guess you have done with the full screen mode or slideshow mode, but we are still at the slide view mode and we are not being able to see the presentation. I guess you are moving ahead in presentation, but we are still at the title slide.
Okay. Oh, I'm sorry. So now is it visible?
No.
Yeah. Again, I will
make it full
do
screen.
present.
Go to presenter mode, slideshow. I guess you need to share the whole screen so that it would be visible.
Okay, so I will again share the screen. Wait a second.
Yes, please.
Now it is visible, ma'am. Hello.
We can see the proposed solution, but still now this is full screen
Now,
and
okay.
we can see the objectives. Correct. You can please proceed.
Okay. So now the objective of this work. Okay. So I will begin begin from starting. Okay. So the primary objective of this work is to design a real-time component detection system using abundant AI. Well, we aim to assist and train a custom object detection model that is capable of identifying various components that are present on the board. Well, another two key objectives first is to deploy the train model on Raspberry Pi, enabling efficient ad level inference without relying on cloud connectivity. And second is to evaluate the proposed system in real-time component detection scenarios. Next is literature review. Here, the literature review highlights the extensive research on real-time object detection using embedded platforms such as Raspberry Pi 5. Several studies have demonstrated the successful deployment of YOLO-based learning model in applications including safety monitoring, healthcare assistance, robotics, industrial inspection, etc. However, existing solutions still mainly focus on either general object detection or industrial automation tasks, and very limited research addresses interactive system that helps the beginner in recognizing and understanding electronic component during practical work. So this gap forms the motivation of our proposed system, which focuses on real-time component detection, especially for educational and industrial environments. Next is the proposed system. Now, this diagram represents the complete workflow of our proposed system. The process begins with a USB webcam, which captures the live video of electronic board. Here, the Raspberry Pi 5 act as the main processing unit. Inside Raspberry Pi 5, the frames are being first processed using OpenCV for image acquisition. Then these frames are being passed to the YOLO model and it performs the real-time component detection. Here, NumPy is used for pre-processing and data handling, while this main Python script is the main logic of the system that controls the overall workflow of the system. Finally, the detected components are then displayed on screen for real time. Now, this is the methodology. This flowchart represents the whole methodology of our proposed system. Here the process begins with initializing Raspberry Pi by setting up the operating system, required libraries, and development tools. Next is the USB webcam that is connected and tested to assure the proper image capture. If the camera does not work correctly, it should be reconfigured before proceeding. Once the hardware is verified, a custom dataset is collected using RoboFlow Universe, and then it is labeled using Label Studio. Then it is converted into YOLO format, and that YOLO model is being trained on Google Colab, and its accuracy is evaluated. If the performance is not satisfactory, then we need to retrain the model using additional data. And after achieving the desired accuracy, the trained model is exported and deployed to Raspberry Pi using SCP protocol. Finally, the Python script is executed to Raspberry Pi to perform real-time detection. If the detection is successful, the system displays live component identification on the screen. And this is how the system works. Next is hardware setup. This is the overview of hardware setup. Here it is visible that Raspberry Pi is connected to the power supply, and USB webcam is connected to Raspberry Pi for live detection of Arduino board. Here targeted board for detection, we have taken Arduino board, and on monitor the detected components are being displayed. So next are results. The result clearly demonstrates the effectiveness of our system. The model successfully detects both small and large components with high accuracy, including critical parts such as microcontroller, then here capacitors, voltage regulator, and polyfuse. Real-time inference was achieved at approximately 6.13 frames per second on Raspberry Pi, which is sufficient for smooth visual detection. So this result confirms the practical flexibility of using embedded AI for real-time detection of components. Next is key observations. Now, from our analysis, we
Just a
observed
minute,
that.
Vishwa.
Okay, yes.
Yeah.
Hello? Yes.
What next? Other slide. Next slide you do have after key observations.
The
It must be
conclusion and
conclusion, right?
future scope.
Yeah, great. Yeah,
Okay.
just a minute. So can we go to the result wala slide?
Okay, yeah.
So I guess you are MTech student, right?
Yeah.
So, but I feel like the result could be demonstrated or represented and portrayed in some systematic manner, such as
Okay.
either tabular form or some
Oh, yeah, yes, yes.
graphically or something else, you know? And just
Yes.
because you have shown, I guess this is the circuit which you have designed, right?
Yeah, yeah. So we have made it a tabular
And
form.
then you are just
We have the accuracy table, but I should have
so
added
where
it.
it is. Have you displayed it?
No, it's not displayed. I should have added it.
Yeah, you have to add it, beta. Because
Okay.
listen, when you are generating some result, calculating some coming to
Okay.
some results with some existing system, existing solutions.
Yes.
This is the innovation, which probably is not matching with some other system, existing system.
Yeah.
And you do not have any other system to compare with. So we generally get other system to compare with because the basic system requirements may vary from system to system
Yes.
or assumptions, not requirements, assumptions,
Okay.
because you must have assumed some basic criteria or system requirement, and then someone other must have assumed something other configuration features or criterias, then it would probably not match, and then you'll not be able to compare the result. But still, if you are being able to get some statistical result, you should put it
Yes.
in the correct manner. And this is not the way at all to represent or put the results.
Okay. So sorry for the inconvenience. I will be at.
Yeah, it is not about inconvenience. I'm giving you the input.
Okay.
I'm giving you the input, and you should keep in mind this
Okay.
for
Okay.
next paper presentation or something.
Yes.
Anna?
Definitely.
Because
Yeah. Thank you, ma'am.
yeah. So your results must be displayed or portrayed very systematically.
Okay. Done, ma'am.
Yeah, you can come to conclusion.
Okay. Okay. So in conclusion, we developed a real-time component detection system using Raspberry Pi and YOLO model, demonstrating effective integration of AI with embedded hardware. The system serves as a practical tool for electronics learning and prototyping, and it also validates that low-cost devices can deliver meaningful AI performance on hands-on applications. Next is future scope. So in the future, this system can be extended by expanding the dataset to include multiple development boards and different IC packages. And to enhance user interaction, voice-based component explanation can also be added into it. Along with that, circuit level guidance and pin function explanations can be integrated to further support practical learning and prototyping. Additionally, this system can also be integrated into robotic platform where real-time component detection can assist in automated inspection, sorting, and intelligent decision making. These are the references. This slide lists the key research works referred to this study. These papers demonstrate the use of embedded AI and object detection on Raspberry Pi across different application domains. Our work builds on these studies by focusing on learning-oriented component detection system. Thank you so much. I'm open to answer your questions.
Thank you, Vishwa. Ma'am, you can proceed with your questions.
Yeah. Does anyone else have any questions to Vishwa? No? Okay.
I have one. Hello.
Yeah, please proceed.
So you mentioned usage of YOLO. Like which library have you used?
So for training YOLO model, I used Alterytics library.
Okay, the question why I asked like particularly this question is because that library has a usage restriction. For example, let's say if you want to productionize it, it's you will have to get the license. It's not something open source per se.
Okay. On Google Colab, we can train that model. It provides free cloud learning platform for training the model. So I have used that.
Yeah, I agree. Like you can train it and we can show the result and build paper also. Like that is allowed. The thing is, when you will go to productionize it, or let's say use it somewhere as a product, then you will face license issues if you don't
Okay.
have license permission from them. And same thing is with Raspberry Pi, the hardware you are using. Academically, they are subsidized machines, but you will require a specific license to use it for commercial purpose. But here, I think it's okay because it's research, just info.
Okay.
Thank you.
Thank you so much for your information. Yeah.
Yeah, so on same line as Praveen has mentioned, I would like to add, like if you want to go for the patenting or some other copyright purpose or for your solution, whatever you have proposed, you have to choose some other better or open source software and
Yes.
the
Yes, we can
better
improvise
hardware.
this by changing or modifying using other platform. For that,
Correct.
I can work on it.
And the major thing you need to remember, Vishwa, is about the results.
Yes,
Presentation
ma'am.
of results was not up to the mark. You can
Okay.
improve it. There is a huge scope for improvement of depicting the results. And as long as possible, it is always better to compare your system results with something else which is existing. And as I told you, if it is not existing, similar to the system, same as your requirements or your assumptions you made, if it is not found, then you can clearly mention that this is the whole new thing we are proposing, and you will land up in something called innovation. Okay.
Okay.
So
Okay.
that's it
Okay,
from
ma'am.
my side. All the
Thank
best.
you. Okay.
Yeah.
Okay, thank you, Vishwa. Tarun, can you present next? I will share the PDF on your behalf.
Yeah, sure. Yeah, yeah,
Yeah,
yeah.
you can start.
Can you? Yeah,
Just tell me when you have to scroll it.
yeah. Good evening, everyone. Uh, could you please go? Yeah. Good
Okay.
evening, everyone. I am Tarun. I'm currently pursuing my bachelor's in artificial intelligence and engineering. My paper ID is 365, and coming to the and I have co-authored it. Can you scroll up, please? Hello. Okay. No. Sorry. Like page one, please.
Here?
No. Yeah.
Okay.
So I have co-authored with Vipna Wilson. She is my guide, and we have been doing quite amount of research in blockchain and energy trading. So my paper is a blockchain based energy trading with reinforcement learned dynamic pricing and automated market clearing mechanism. So coming to the introduction and motivation, page one, please. Page two, please.
Yeah.
Uh, uh, so in the recent days, the energy trading has been a more booming industry, and with the help of that, the grids have been uh, evolving day to day. But most probably, today's grids are like the energy is being transmitted from the central grid to the prosumers, and because of that, there are more middlemen in between them. Because of that, the trust deficit is being placed here, and price volatility is missing here. Because of that, the starting pricing fails during the peak demand time. Page 3, please. So to overcome with this problem, we did a literature review. So with the help of these papers, we analyzed that some the research gaps are existing in current methodologies. So we proposed a new framework with the help of DQN and proof of work. We can clear the market. We can clear the market and with the help of the RL and blockchain security, peer-to-peer trading can be implemented. Please, page 4,
Yeah.
please.
Tarun,
Yes,
may I
ma'am.
disturb you for a while? Yeah. So
Yeah, ma'am.
before proceeding further, I guess you made the presentation in LaTeX, right?
Yes, ma'am.
Yeah. And you are UG student?
I am, yes, ma'am.
UG student, yeah. So can we just have the clear explanation of motivation behind your work first before we move to the next slides? And along with motivation, I do need the justification for why blockchain.
Yes, ma'am.
So,
Uh,
and at the same time, the third point you can focus on is like, have you explored all the aspects of blockchain? I mean, all the challenges blockchain will give you, and whether your system is going to sustain with all those challenges the blockchain is having.
ma'am,
Do you have solution for that?
ma'am, to be frank, this is my final year project, and I have been working in the blockchain domain from my second year onwards. So
Okay, good.
I have been exploring different types of consensus mechanisms. So
Correct.
in these consensus mechanisms, in the blockchain domain in particular, and the energy trading caught my eye. So even our guide was interested in that domain. So we were trying to mix both domains to make sure that it is profitable and sustainable. We tried with the different languages for smart contracts like Ethereum. I mean, in Solidity, we wrote some smart contracts and we published few papers before as well. Coming to the
Yeah.
this paper in here, really. Uh, so what we thought was like, why go for the existing one? Why not create our own consensus proof of work thing? So we came up with a Python code, which is our own proof of work, and we programmed it. It is custom. I don't mention it as own. It is custom. Uh, so with the help of that proof of work, we were able to make sure that it is sustainable to the small extent. And one more thing is like in the recent, the blockchain is most secured data structure as of now. But I guess it won't be secured in the future because of the quantum computing. So I guess like it is sustainable for a short amount of future.
I would like to add something to this, Tarun.
Ma'am, yes, ma'am.
Because you mentioned about quantum. So
Yes, ma'am.
quantum future we right now are not sure about. Everyone is generating and designing the quantum safe encryption decryption algorithms, but those are right now not required. As in, we should be ready for future. Obviously, that's great, but then still, this is the project or the solution you are giving, which is kind of supply chain. Is it
Not
supply chain
supply.
kind of project?
Like
Or you are
it's not
proposing just the mining algorithm?
like not the mining algorithm, ma'am. Like the mining algorithm is there, but it's not the major part. We are proposing the deep learning and how this market works actually. Like RL, reinforcement learning part, and how this works actually. The mining algorithm is like in the future, like the next step for this paper. Like we would like to make it much more stronger and make nouns make hard to get the nouns.
Okay. So you are using same concept as of the proof of work uses nuns for calculating the uh, solving some hash puzzles.
Yes, ma'am. Solving for some hash puzzle, we will get the nouns, and that for getting that nouns, it takes the time and the mining happens, etc. Like that.
Correct. Okay, ठीक है,
Yes.
चलो, we'll proceed and let's see.
Yeah, coming to the methodology, we have four layers here. Initially, the participant layer, in which the all agents will be interacting with the system, and intelligence layer. This is the pricing engine for which we used deep QNN, and for the blockchain layer, we used custom proof of work, and for the contract layer, we used automated market clearing and settlement. So this is a smart contract. Can you go to the next slide, please? Coming to the next slide, this is DQNN. So we may get the doubt like why DQNN instead of the traditional RL way. So with the help of the DQNN, it gives more accuracy compared to the traditional RL way, and the pricing can be done neatly, and the goal, which is convergence to the market equilibrium, can be attained. So here every RL has three parts, which is state, action, and reward. Here are coming to the states, it is demand, supply, and last price. This is the state, it is a tuple. And coming to the actions, it is the price, whether the price can be increased or decreased and hold at the particular price. And coming to the reward, so the profit should be maximized. So that's the reward. Uh, so with the help of the QNN, we were able to make sure the memory is not consumed for holding the state action table in with the state action table. Instead of that, the Q values can be simply taken into the consideration, and the best action can be chosen with the help of the state and Q value. Next, please. So coming to the automated market clearing, so this is the smart contract part. So so the smart contract is basically an automated kind of thing which performs the tradings in our blockchain. So here are like certain rules. So the first one is the bids and asks. So the bids and asks will be sorted in their respective ways. And after that, there are some rules like the uh, buying price should be greater than or equal to the selling price, and the quantity should be able to match. So we should be able to match the quantity, and the ledger should be updated after a certain amount of trades. So this is the flowchart how it works. Next, please. So coming to the experimental setup, we used Python 3 language, and for training the neural network, we used PyTorch. And coming to the blockchain part, we used custom proof of work. And for the interaction between the layers, we used Flask APIs. And after that, for the simulation parameters, we used 100 agents, which are 50 prosumers and 50 consumers. And we simulated a 30-day market cycle. And coming to the ledger, after every 10 transactions have been implemented, those 10 transactions will be added into the blockchain. Can you go to the next place, please? So these are the results. Coming to the results, like average mining time. So for one block to be mined, it's 5.12. So here the difficulty level increase means, so it's basically the difficulty of our mining algorithm. So like we did not concentrate much on that here. Uh, Coming to the mining time, so it is 5.12. So for mining a block, it will be taking 5.12, and for hash rate, it was able to solve 5.6 hashes per second. So that means it will be uh, searching for 5.6 hashes in a second to find its particular nouns in the given cryptographic puzzle. And with the help of this, we were able to estimate that 51% of the attacks can be stopped with the help of the difficulty levels of 5 and 6. The 4 is usually like not that good. Can you go to the next, please?
Tarun, I have one
Yes,
question.
ma'am. Yes, ma'am.
Yeah. So go to the previous slide. So this table you could draw is difficulty
Yes, ma'am.
table 4, 5, difficulty level 4, 5, and 6. This you
Yes, ma'am.
have, I mean, experimented with some program, right?
Yes, ma'am.
So which program did
Like,
you write? I mean, which language did you use?
ma'am, like I can explain the consensus algorithm like in a
No,
small way so
I'm
that
not. Listen,
Like
listen.
I can.
I'm
Okay,
I'm
ma'am.
not I'm not doubting your coding skills or something else. I'm just asking you the
Uh,
language used because it matters. It matters a lot. Whether you use
uh,
Python, you use C, or you use Java, it will give you different result and different timing because C is the kind of middle level language and it
uh,
will give you the faster result and
yes,
probably
ma'am.
will help you in computing fast. So I just wanted to know these results you plotted or not plotted, sorry, you tabled after programming in which language? These are
Ma'am,
observation,
for
real-time observations, right?
yes, ma'am. For my consensus algorithm, I used Python and time calculation, everything I did in Python as well, ma'am. Like I have
So you put these
learned.
timestamps and then you had the real-time time subtraction kind of logic for calculating the
Yes,
time
ma'am.
required.
Yes,
Okay,
ma'am.
so
In
you had
Python.
timestamps and then you subtracted them.
Yes, ma'am. Like to be frank, this SHA-256 algorithms and all that can be easily implemented in Python. Apart from C, like it's a kind of difficult thing, and we can concentrate more on the algorithm part if we have easier language. That's what
No, but
we thought.
anyways, even if you want to focus on calculating the constrained hash value or conditional hash value, you need not to code for SHA. You can use the ready API, which are already available in Java and C even. So the focus
Okay.
is on generating the puzzle solving hash value, such as the hash value which starts with 40, 50, or 60. And what
Yes,
was
ma'am.
your underlying processor hardware configuration used for this?
Like hardware thing is like
Processor of
like
RAM.
okay, ma'am. So this has been run on like 4 GB RAM, ma'am. And
Huh?
processor is
Did you say 4 GB?
yes, ma'am.
Okay, and what processor?
Like processor, I'm not sure, ma'am. Like it
See,
may
because it,
be
it matters a lot. Listen. It matters a lot.
uh,
If I give you the same matrix, I mean these same parameters, and I ask you to execute the same code, exact same code with different processors, probably you will get different readings.
yes, ma'am.
If I do it with i3 processor, you will find the readings different or the time differs from the processor i7 or even
Okay,
i7 earlier generation and i7 recent generation processors will give me different readings,
okay, uh,
right?
ma'am.
So it is very much important to mention, first of all, if you are not mentioned, the hardware and software, both configurations.
Yeah,
Do
okay,
you have
ma'am.
slide for it?
No, ma'am. Like it is basically trained on my laptop, ma'am. Like it's a 4 GB RAM and i3 processor.
Whatever it is, you should
Okay, ma'am.
mention the software and hardware requirements whenever you are taking such real life results or real time result and I mean by program, and these are not in asymptotic notations, right? These are real
Yes, ma'am.
results, real time
Real
results.
results.
If they are in asymptotic notations, it does not make any difference what configuration you use because time does not make any difference. You are representing asymptotically. But here
Yes, ma'am.
you should mention the configuration. That's very much important.
Okay. Like we'll improve further,
Okay?
ma'am. Thank you.
Because it matters. Yeah, it matters. You need to remember it for further presentations or paper publication. Okay?
Okay, ma'am. Sure, ma'am. Like
And a
uh,
last question.
so
So
yes, ma'am.
why you could not go to difficulty level 7?
Like we thought it was initially I ran, ma'am. Like it is taking more
Hmm?
time to mine a single block as well. My life, my like our my hardware the present with me is not that
Absolutely.
compatible.
Absolutely. I'm asking you these questions because exactly same kind of analysis I have done already. I could run up to
Okay.
difficulty level 6 and then I have tried for 7. It didn't work with my laptop configuration even. That's why I'm
Yeah,
asking you
ma'am.
whether you have done it at your home or not. Yeah.
Yeah,
Okay,
ma'am.
good,
Yeah, ma'am.
good, good.
Yeah, and this is the snippets from the GUI as you can see: live market summary and order book, decentralized user submission interface. Can you go to the next slide, please? Coming to the next slide, this is the graph. So these are the reward and episode. So the converged state, for that converged state, the reward was around 30 points, 30.8. And initially our loss was near 1.098, and it was drop it to 0.11 in the further episodes. So this is, I can say that this is like it performed well compared to the static models like double auction mechanisms and others. Can you go to the next slide, please? So so comparative analysis. So if we use the traditional grid way, having a central grid and the energy will be transmitted with the help of the central grid. These are the differences which you can see. The central grid is for the structure, it is centralized, and proposed system is peer to peer, it is decentralized. The pricing is fixed and static, it does not work at the peak time. Proposed system RL based dynamic, so it is the pricing is dynamic. So for the trust process, it is a central, and there is no trust. Since the blockchain is a public ledger, it can be trusted. For the transparency, it is low, and the proposed system, it is high, it has high transparency since it is decentralized. Next slide, please. So coming to the feature scope, as of now we are thinking from moving from proof of work to the proof of stake with the help of the better GUI, and to handle right now it is handling in like 100 users. In future we are planning to handle big the we are planning to make the GUI handle big number. And coming to the privacy, we are trying to use zero knowledge proofs so that the user can make sure his traits are not revealed to everyone. And cross chain thing. So coming to cross chain, what I meant is like different grids, so the user can buy energy from the different grid in which ecosystem he is not currently present. Next slide, please. So these are the references which we considered. Next slide, please. Next one. Yeah. So coming to the conclusion, I can say that so this is a modular Python blockchain for energy markets. The DQN agent decides what price you need to sell, and security is verified, and it's a secured blockchain network to a little extent, not further. Thank you. I'm free to answer any questions.
Ma'am, you can proceed with the questions.
Yeah, Tarun, can you
Ma'am,
go to
yes,
the
ma'am.
references slide?
Yes, ma'am. Like, yeah.
Ma'am, should I share the? Okay,
Rajanandini,
ma'am.
yeah. Please. Just the references slide. I want to go through the references.
Yeah.
Hmm.
Like here, basically, like 4 to 5 papers are published by myself, ma'am.
Okay, so it is self-citation. Okay.
Yeah, ma'am.
Yeah, it's okay. It's okay. Not an issue. That's a great idea actually. But then go to next slide, please.
Next.
Mm, yeah. Okay. So you have enough transaction papers. How many transaction papers you have referred? 2 or 3? And then
Like,
okay.
yes.
You do have transaction paper. Yeah, good going.
Yeah.
Okay, Tarun. I don't have any question. I asked whatever I felt
Thank
like
you.
during the presentation only, hai na? Rajanandini, you can ask
Yeah.
next participant to please present. Thank you.
Yes, ma'am.
Thank you, ma'am.
So for the next presentation, I would like to call Abhijit for the paper title Smart, Immersive and Connected, Emerging VR, AR and IoT Trends in Brand Experience of Indian K-12 International School. I kindly request the presenter to start with the presentation.
Thank you so much, Rajnandini.
Yes, you can share your presentation.
Is it visible?
Yes, it's visible.
I would just like to thank SmartCom for giving me this opportunity to present this topic. My name is Abhijit Vairagade, and I'm an industry professional working in marketing department, and recently shifted, in teaching profile, that is assistant professor at Mumbai Educational Trust, that is located in Mumbai. I am also pursuing my PhD, and I have written this research paper along with my guide, Dr. Abhishek Mukherjee. I'm currently pursuing my PhD from Dr. Vishwanath Karad, MIT World Peace University, Pune. My topic is smart, immersive, and connected. That is emerging VR, AR, and IoT trends in brand experience of Indian K-12 international schools. When I say Indian K-12 international schools, is basically the international school that offers international curriculum like IB, that is International Baccalaureate, and Cambridge International Schools. So these are the international schools, basically, who use this kind of technology, as they charge premium also. Uh, so my study overview is, the study explores how VR, AR, and IoT influence brand experience in Indian K-12 international schools. Second is focus on immersive and connected technology shaping perceptions of modernity, transparency, and trust. 50 stakeholders, that is across principals, teachers, IT staff, and parents, participated in a qualitative study. And the findings is basically VR, AR enhance experiential touch points. That is, Internet of Things reinforces safety and communication, and a model is proposed at the end of this presentation. A conceptual model links technology adoption to brand experience, trust, and advocacy. The introduction is digital transform reshaping K-12 international education in India. Post-COVID, of course, there are a lot of schools that are being using technology. School face intense competition. Experience is the new brand differentiator. Since international schools, which are there in the Mumbai market, are offering very premium price. When I'm talking about premium price, it's coming around 5 lakhs to 10 lakhs, for a normal grade 5 to grade 8. What basically K-12 International School stands for is, K stands for kindergarten till grade 12. So K-12 International School, that is the meaning of K-12. Brand experience in K-12 is emotional and trust based. VR, AR create immersive experiences. IoT enhances safety and communication. Parents value innovation, transparency, and future readiness. VR and AR technology is creating immersive educational experiences, that is virtual tours of campuses, interactive brochures, hands-on teaching models. Now, in Mumbai, there are a lot of schools, but due to traffic issues and all that, they first would like to have an experience. So this becomes a marketing tool for an admission counselor who can actually help them to experience the school. Because in school time, working hours also, there are a lot of walk-ins. We cannot allow the students to show the entire campus, wherein this virtual reality tools have been are being used by the schools. IoT is also a multi-dimension to the supplement points that connects your child's right to school functions like smart classroom. So a lot of learning applications wherein the schools are using VR as a platform. Literature review. So these are the papers that has been done a literature review on. And what the basic idea that has come was, the existing studies consistently indicate that immersive technology such as VR, AR, and Internet of Things enhance student engagement, learning depth, and overall educational experiences in K-12 settings. And these technologies act as a strong differentiators when you are actually trying to position the school into the market. So that is basically helping the brand perception, trust, and enrollment decisions. So research gap is challenges related to infrastructure, teacher readiness, and resource constraints may affect consistency in brand experience delivery. The literature emphasizes the need for strategic adoption and continuous innovation to sustain long-term brand value and credibility. This gap inspires this study, which intends to investigate how emerging smart IoT and immersive VR, AR technologies are changing the brand experience and thereby advancing trust and advocacy among parents in Indian international school. Same basis, I have proposed the model, in the coming slides. The objective is to explore the impact of VR, AR, and IoT on brand experience in K-12 International School, to understand how technology-enabled experiences build trust, advocacy among parents, to assess the role of school readiness in strengthening or weakening this relationship, and to propose a conceptual model explaining technology-driven brand experience formation. Theoretical framework that has been used for this model are the three foundational theories. One is the experiential marketing theory by Skimmett 1999. Then technology acceptance model that which is being given by Davis 1989, and brand relationship theory by Fournier 1999. It basically talks about how strong and coherent theoretical foundation basically helps in conceptual thinking. Mostly when it comes to the usefulness and ease of use moderated by school readiness, teacher training, and digital familiarity. So this is the research methodology. Total population size was 140 international schools in Mumbai, but not all are using VR AR. So out of which only 25 schools have been using this particular facility. Qualitative exploratory design was adopted. Non-probability purposive sampling for rich and contextual insight. Thematic analysis was used to identify patterns and develop conceptual model. Semi-structured interviews were conducted. Some of them were for 30 to 45 minutes, and these are the details of sample composition. So 10 participants were taken from the school leaders, that is principal and directors. Marketing admission counselor 10 participants, teachers 10, IT and edtech administration, and parents from international schools. Though the student feedback was not taken into consideration, but the same can be done in the future scope of research. So these are the stakeholders from whom the data was taken and collected. This themes have come out. These are the sub themes. So initially, whatever codes were then, it was translated into sub themes and then into main themes. And this is what the conceptual model component came out. So these are the entire themes and sub themes that has come. And this is the conceptual model. So the model basically shows that VR, augmented reality, virtual reality, and internet of things basically helps in enhancing brand experience. This positive technology enable experiences and strengthen trust, particularly in terms of safety, assurance, transparency, and perceived innovation. So there are a lot of parents, in GPS tracking and all that, where in internet a lot of CRMs is softwares which schools are using, and also mobile apps. So every parent has this mobile app wherein they can actually see the tracking of their the students, where the bus is reaching. So that basically creates a trust and also a safety parameters, since every information is handy. Increased trust subsequently leads to advocacy. So of course, when technology is adopted by the international schools, there is a positive word of mouth, and people then basically starts talking about the school, that it is basically giving you that kind of advanced protection when it comes to also with the premium kind of fees. The strength of this relationship is influenced by school readiness. So when I'm talking about school readiness, it is about level of adoption, how schools are basically adopting it or not adopting it, or basically using it properly or not. Teacher training is required. Infrastructure, when it comes to virtual reality and augmented reality, even teacher training is required in order to operate those gadgets. Infrastructure stability and digital comfort among parents. Even parent training is also being given by the schools, how to basically track their students, internet of things, augmented reality, and VR basically. So that is something. So what it says is higher school readiness amplifies the positive impact of VR, AR, and IoT on brand experience, while the lower readiness weakens this particular thing. So these are the moderator factors, wherein if it goes high, the level of advocacy and trust also increases. The scope for further research is, of course, now this is something, this is the model, but it also needs to be proved quantitatively. So future research can quantitatively validate the proposal, by taking certain hypotheses into consideration. Further research may explore students' perspectives independently. That is something which is not being considered. We've just taken, only the stakeholders part. Future studies can investigate, emerging technologies such as AI-driven personalization, metaverse learning environments, and learning analytics, and their role in shaping next generation school brand experiences. So that is something, the scope of future research is. This is the conclusion. So study contributes to understanding tech-driven brand experience in K-12 schools. Conceptual model links VR, AR, IoT to trust and advocacy. highlights the importance of school readiness and stakeholder alignment, and of course future research. That is, quantitative validation is required along with longitudinal studies and broader geographies. These are the key references. Thank you.
Thank
Hello.
you, Abhijit. Ma'am, you can continue with your questions.
Yeah. Abhijit, can you go to the motivation slide? Do you have motivation slide?
This one, ma'am?
I guess, yeah. Motivation. Okay. Can you tell me in short the motivation behind this work?
Yeah, so I was working as a head of marketing at DY Patil International School earlier, and
Okay.
from like 8 to 10 years, I was into the marketing department, and
Admin.
wherein, of course, since when I said it's a premium, so understand that 11th and 12th fees is around 20 lakh rupees. So when it
Correct.
comes to 20 lakh rupees, when I'm spending for my child for grade 11 and 12,
Hmm.
there has to be some differentiators, and wherein the technology plays a very important role. Now, some
Hmm.
schools have a great infrastructure, but some
Hmm.
schools do not have great infrastructure. So, on
Okay.
what particular basis, they can charge that kind of fees? So,
So
therein
that is what you
the
are
technology
doing the
comes in.
analysis.
So,
Okay.
that's
Okay.
the motivation for me.
But is it inclined or I mean in line with your PhD problem statement, or this is
Yeah.
altogether
So
different topic?
my topic of PhD thesis is brand engagement activities in K-12 international schools.
Okay.
So,
So it
so
is kind of sub
again, this
problem of
is
it.
brand engagement because I'm engaging parents. So, if the
Hmm.
no, what problem is that in South Mumbai location in your Mumbai, so the
Hmm.
parameter is around 12 to 14 kilometers. So,
Hmm.
any which ways, if they want to have some kind of experience, when they are coming in. So that is
Hmm.
something, on weekdays also there are a lot of parents who are coming in, but then we are not
Hmm.
able to we are not allowed to show because of the safety of the students. During that
Correct.
time, this kind of technology really helps us, and that also
Hmm.
creates an exposure. The second thing is, when teachers are giving this kind of gadgets to also experience certain kind of learning thing. So when I'm talking
Hmm.
about like a process of photosynthesis that needs to be taught to the child, so it can there are certain learning models that are basically done with the help of virtual reality, and
So
that
you mean these models you are designing or proposing, right?
no. So there are a lot of agencies basically, and these agencies basically give you this ready content to showcase
Hmm.
it in the classroom. So it's a matter of like getting those gadgets, and they also provide gadgets along with the software. And then
Hmm.
this particular thing is the teachers are trained to use particular this softwares, and then students are given this kind of exposure. So they also then speak to their parents, and then parents basically give their feedback, and also when they are talking in that parent community, they're always
Hmm.
talking good about. So for marketers, it's word of mouth is very important, and that
Okay.
gives us more and more referrals, and more and more inquiries because of that. So we are establishing,
Okay.
so it helps in brand reputation, building a trust,
So
apart from.
it is about getting more admissions or making
Yes,
parent
yes, yes.
aware
Finally,
of the
finally, the
infrastructure
revenue is
is
the
the
main
aim.
motive. But
Aim.
at the same time, if I'm charging premium, I have to be different. So it is also acting as a differentiator.
Okay. Okay. Okay.
Yeah. So
Yeah, I
if
got the idea.
yeah, so if good infrastructure along with good technology is win-win situation. Those since in Mumbai, the area is not that much. There are international schools who do not have great infrastructure, but they want to charge premium, so they can include this technology. So again, they can say that we are using this kind of technology, and that is how the schools are now marketing.
Correct. Correct. Okay. Fine. Seems okay. So no questions from my side. I have discussed whatever I had in my mind. Okay. Thank you.
Sure.
Thank you, Abhijit.
Thank you so much, ma'am. Thank you.
Thank you, Abhijit. Can you please unshare your screen? Okay. So for the next presentation, I would like to call Nitika Goel for the paper title Bridging the Future with IoT, Industry Use Cases, Challenges and Open Research Issues. I kindly request the presenter to start with the presentation.
Thank you for the introduction, Rajnandini. Am I audible clearly?
Yeah, you're audible. And it's humble request to complete your presentation within the span of 8 to 9 minutes.
Sure. Is my screen visible also?
Yes, it's visible.
Okay. Thank you. May I start, ma'am?
Yeah, you may start. You may start.
Thank you, ma'am. Good afternoon, respected session chair and my fellow researchers. I'm Neetika Goel, pursuing BTech in Computer Science Engineering and Artificial Intelligence from IGDTUW Delhi. Today, I'll be presenting our paper titled Bridging the Future with IoT, Industry Use Cases, Challenges, and the Open Research Issues, which focuses on understanding how IoT is transforming multiple industries, the key challenges which are limiting its adoption, and the open research issues that must be addressed for secure, scalable, and a future-ready IoT ecosystem. This will be the flow of our presentation. I'll start with the introduction, moving on to literature gap, literature review. Then we'll discuss the research gaps, what are our research objectives, and briefly discuss about the applications, challenges, and open issues that we got from our study, the conclusion, future scope, and we'll end with the references. So starting with the introduction, the Internet of Things represents a rapidly expanding ecosystem of interconnected devices that collect and exchange data. Its applications span smart cities, healthcare, industry, and home automation, which enables intelligent and data driven operations. The integration of IoT with cloud, fog computing, and AI further enhances its capabilities, especially for real time applications. However, growing privacy and security challenges still remain a major barrier, which motivated the need for comprehensive analysis and improved IoT security solutions. Existing research demonstrated that how IoT enables automation, real-time monitoring, and intelligent decision-making across these sectors. Most studies primarily focused on application-specific implementations or enabling technologies like sensors, communication protocols, cloud computing, and artificial intelligence. Although critical challenges such as security, privacy, scalability are frequently identified, but they are often studied in isolation rather than within a unified system level or a
Yeah, you are not
architectural
audible.
framework. Hello, am I audible now?
Yes, you're audible.
Okay, so
Rajnandini, can you hear her?
am I audible clearly?
Yes, you're clearly audible.
Uh, Ma'am, are you able to hear me clearly? Hello?
You're audible, Nitika.
Okay, so may I continue?
Yes.
Okay, thank you. So screens like are moving like, right? Like I'm on literature
You're
review
on
slide.
literature review, right?
Yes,
Yes.
right. Okay, I'm continuing. So, this observation motivated the need for a more comprehensive and integrated analysis, which our work aims to address. So, these are the research gaps that we identified. First, there was a lack of comprehensive study that jointly analyzes the IoT applications with its challenges across multiple industries. Second, the existing research shows absence of integrated evaluation of IoT security and privacy issues, which spans hardware, software, and network layers. Third, the scalability and real-time performance in heterogeneous IoT environments still was very underexplored. And finally, finally, there was an insufficient analysis of future research directions, particularly in the context of like emerging technologies. And these gaps laid the foundation of our work. So the research objectives were: first, we aimed to analyze IoT applications across various sectors such as healthcare, agriculture, transportation, and other industrial domains. Second, we examined the security and privacy challenges across various hardware and software and network layers. Third, we evaluated the architectural limitations, which also affects the scalability and real-time performance of IoT devices. And fourth, we identified the future research directions for a secure and sustainable IoT ecosystem. So these were the applications of IoT that we studied. First, in healthcare, IoT has significantly transformed this sector by enabling remote patient monitoring and also telemedicine services through connected medical devices. This has enabled the doctors to make faster and more accurate decisions and also improve the patient care, while it also reduces the burden on healthcare systems. In agriculture, IoT enabled the smart farming by using sensors and control systems that monitor crop conditions and environmental factors. And this has allowed the efficient utilization of resources such as water and fertilizers and pesticides, and also improved crop productivity and sustainability. Then in transportation, IoT plays a key role in modern transportation systems by having a GPS tracking system and a real-time route optimization. These capabilities have improved the logistics efficiency and have reduced fuel consumption, enhanced the overall road safety and transportation performance. In traffic monitoring systems, IoT has used sensors and roadside infrastructures, which has collected real-time traffic data, which helps in allowing intelligent traffic signal control, helping reduce congestion and travel time, and also improve the mobility in the smart cities. Then moving on to the challenges within the IoT systems. So first challenge was device identification. Secure device identification is very difficult due to the vulnerabilities in existing naming and authentication mechanisms. Second, in pairing physical systems, when they're interconnected, a breach in one device can compromise the entire ecosystem and can lead to expose of personal information. And third, data authenticity. Like ensuring data authenticity is very critical, since fake data can severely impact the decision-making process in sensitive IoT applications. Then fourth, data accessibility. Ensuring continuous data availability is very difficult due to limited device resources and DOS attacks. Also, fifth, deployment of privacy approaches. So, privacy protection is also constrained by hardware limitations. Like they require efficient, lightweight security mechanisms to work efficiently. And then sixth, data confidentiality. So, maintaining data confidentiality is also very a major concern across IoT networks due to resource constrained devices that we have. Next, so these are the several open issues that we encountered on our way. So first was ensuring a reliable authentication and authorization still remains challenging because IoT environments involve highly heterogeneous services which operates at massive scale. And second was like achieving an end-to-end data security, which is very difficult to achieve because of absence of widely adopted and standardized protocols. And third, ensuring the user data privacy is a very critical concern, as they continuously collect, transmit, and share sensitive and personal data. So we need to establish trust among the users. Also, establishing the trust among diverse IoT components and stakeholders is also necessary because of constantly changing interactions that are happening. So to conclude, this study highlighted how IoT technologies are increasingly enhancing the daily life through intelligent and interconnected devices. Our analysis showed that IoT applications in healthcare, agriculture, and transportation contribute significantly to the improvements in safety, logistics, efficiency, and traffic management. However, despite these advantages, there are also significant concerns like privacy, security, and data authenticity that still remain key barriers to a widespread IoT adoption. Additionally, the existing studies also exhibited limitations regarding scalability evaluation, real world validation, graphical analysis, and energy efficiency, which indicates still there is a need for future investigations in the domain. So, based on the findings of this study, we also identified several future research directions. First was real world validation. As we've already discussed, that it is essential to evaluate the reliability of IoT systems beyond just simulation based studies. Second was designing an energy efficient IoT framework, which can like support long term deployments. Then third is adding explainable and interpretable AI so that it can enhance the data integrity, transparency, and security. And finally, AI-enabled security mechanisms can be integrated, which can improve the system resilience and threat detection works. These are the references that we used in our study. And thank you for your time and attention. I would like to thank my co-authors and the conference organizers, and I'll happy to take up any questions if any.
Thank you, Nitika. Ma'am, you can proceed with the questions.
Yeah. So this is kind of a survey. Just give me a minute. Just give me a minute so that I come out of this noisy environment. Just
Sure, ma'am.
can you hear me now?
Yes, ma'am.
Yeah, great. So I want you to go to Nikita.
Hanji,
No,
ma'am.
sorry, your name is Nitika.
Nitika, yes, ma'am.
Yeah, sorry. So references section. Can we go to references section?
Yeah, sure, ma'am. These are the references.
Yeah. Okay. And then okay, good. Okay. And I guess you have identified the challenges.
Yes, ma'am. We have identified various security and privacy issues, but I have only kept a few in this PPT to respect the time and.
And those you have not addressed, right, in your work, current work.
I have not addressed them yet, ma'am, but I am hoping to address them in my future works. I am currently working on a systematic literature review based on this topic only. So we have a more detailed analysis of what has been explored and what has not been explored yet. So I can then move forward with the new approaches that we can put forward to uh, help improve these challenges.
Mm-hmm. Okay, it seems okay. Okay, Nitika.
Thank you so
Okay
much,
for
ma'am.
yeah, okay for me. Thank you.
Thank you so much, ma'am. Have a great day.
Yeah.
Okay, thank
Okay.
you, Nikita. Can you please answer? Okay. So for the next presentation, I would like to call Viranji for the paper title IoT-enabled smart irrigation system. I kindly request the presenter to start with the presentation.
Hello. Milan, one of my student, Milan, is already there, so he is going to present. So he will share the, yes.
Okay.
Uh,
My screen visible to
Yes, it's visible.
Good afternoon. I am from near my university. Today I am going to present paper titled IoT Education System. Are Dhaval Shah and this is the presentation.
When your voice
Where
is
your voice
breaking,
is breaking.
your voice is breaking. We are not being able to hear you.
Hello. Milan, if you are using any gadget, then kindly remove directly from the laptop only. You can just present.
Let me try. Hello.
Hello.
Yes, you're audible, Milan.
Here. This is a flow of movement. First, I will discuss introduction, literature, research contributions, a proposed system, and evolution, conclusion, and future.
Milan, your voice is still breaking.
Hello, Milan.
Me,
Hello.
other try to.
If you are using any gadget, then directly you just make it on.
No, I'm not using any gadget. I'm just presenting from my.
You can present later, Milan, when your network is. Are you presenting?
Am I already?
No, your voice is still breaking. Can other member present? Mr. Viranchi, can you present instead of Milan? Is it okay with you?
Let me check with the condition. So it is, I mean, next presentation
Okay,
getting
we will go
completed.
with next presenter.
Yes, yes, yes. Then I think if it is not available, then I will present.
Okay.
Okay, we may go with the next presentation.
Yeah, it's okay. And it's humble request to complete your presentation within the time span of 8 minutes. Everyone, please take this into consideration. For next presentation, I would like to call Tanvi for the paper title Next Generation Urban Health Digital Twin, a disease-aware smart city framework powered by multimodal AI and edge cloud computing. I kindly request the presenter. Are you there,
Yeah.
Tanvi?
Yeah, I'm
Yeah, you can
present.
start with your presentation.
Good afternoon, ma'am. I would like to thank you for giving me this opportunity. Today, me and my co-author Ananya will present.
Is my screen visible?
Yes,
No.
yes, visible.
Okay, yeah, now it's visible.
Okay, okay. Good afternoon, everyone. And our paper ID is 251. Paper title Next Generation Urban Health Digital Twin. Tanvi would continue with the presentation further. Thank you so much.
Can you click on that present button?
I am presenting only. Is my screen not visible?
No, that arrow, like at the very right.
Yes, I did it.
Okay. Uh, so I'll start with the introduction and motivation behind our research. Uh, the urban digital evolution, it is basically the modern smart cities are increasingly dependent on networked cloud-based infrastructures and billions of IoT devices, which significantly expands the potential attack surface for advanced cyber threats. Traditional perimeter-based security models are no longer sufficient to manage dynamic access, insider threats, and the rising sophistication of AI-fueled cyber attacks, and the drive for resilient health systems. Recent global crises have highlighted the critical need for cybersecurity models that can effectively respond to the multi-vector attacks on urban health infrastructure. By integrating edge cloud computing with a zero trust architecture, we can create a never trust, always verify environment that ensures
Ananya,
real time privacy, preserving
Ananya,
disease. Yes.
just a minute.
Uh,
Hold on. Can you hear me?
Ma'am, Ananya is presenting and Tanvi, I
Yeah,
am speaking.
yeah. ठीक है, Tanvi. So who will be answering the question? See, let us not have
Ma'am,
separate
both.
question answer section, है ना?
Okay.
We'll do it in line,
Yeah, sure.
because instead of collecting the questions and then asking at the end, better we'll collect it in the connect to the questions in line. So can you tell me the real motivation behind this work and what exactly your problem statement was actually too long. We could hear
Okay.
it, but then
Ma'am,
it was like
actually,
bit less.
it's just the motivation and introduction. Problem statement I haven't moved to. It's in the next
It's
slide. It's
okay.
short.
It's okay. So I want you to give me the motivation, the actual motivation behind your work. What is the motivation?
Yeah. Ma'am, actually, we are IoT students only. Like, we are doing CSC in IoT. So, like, we are very well versed with the technology. So, we wanted to build a system that can integrate, like, that can be used in the real time. We want to propose such a solution for this.
So solution for what? Solution for what you want to get?
Solution like for smart cities, we wanted to add cyber security and everything to IoT devices because IoT devices are very much
Okay, I got you.
yeah,
So
yeah,
you want to design the system. I mean, you want to contribute in smart city solutions, right?
yeah,
And within
yeah,
that city solutions, you want to make the solutions secure. You mean you want to give
yeah,
the
we want to make it
safe
secure.
solution. Okay.
Yeah.
And as you mentioned, you are focusing on security and you did not focus on privacy.
No, it's cyber security and privacy, like edge computing we are using so that
Excuse me.
privacy and everything is like focused.
Focused. Okay. ठीक है. So so you identified the algorithms or the solution approaches which are available for the edge computing devices, security solutions
Yes,
available for edge computing devices? Okay, you could find those. Okay. And then are you proposing a new solution or you are analyzing and experimenting and comparing existing solutions only?
no, we are proposing a five-layer architecture actually.
Architecture. Okay, so it would be
Yeah.
great if we come to the architecture point. Can you go to the
Yeah,
architecture?
sure.
Am I
Ma'am, shall I
audible?
continue?
Yeah, but where is the
Okay, ma'am,
architecture? I want.
Ananya will present this framework.
Okay,
Yeah.
so we have proposed a UHDT framework for our problem
So,
statement.
don't you have the architecture diagram?
Ma'am, yes, ma'am, we have.
So, will we go to can we go to the slide,
Okay,
please?
ma'am. Just a minute, ma'am. Just a minute. This one, data flow architecture.
See, either the diagram can be data flow diagram or it can be system architecture. Do we have some standard like data flow architecture?
Yes, ma'am. Basically, in our proposed model, we have focused on the architecture flow, like how the data would flow in the levels. So it's kind of a five layer. Mainly five layers are there in this architecture.
And what layers you can identify? Can you list out the layers of your architecture?
Okay, so ma'am, first layer is data acquisition, and first two layers would be data acquisition and integration.
Huh?
And the third layer would be the digital twin core layer, where the processing would take place. Fourth and fifth
Okay.
layer would be the intelligence and governance layers. Uh, So this is kind of a five-layer architecture, and the flowchart which is shown here, it's like these are the detailed, elaborated processes. Like I would say, like the when the data moves into the edge processing, where it is filtered and integrated with the federated learning repository to maintain the privacy, which you were talking about, and then the process data then feeds into the digital twin simulation for AI-based forecasting.
So are
Then
you focusing on some specific edge computing devices or specific edge computing equipments?
No, ma'am, we haven't focused on any specific equipments because it was a task given by our teachers as we are currently in our final year. So, but in our last semester, it was the task given by our teachers in which we have to just propose the model that could be used, that could be a potential model for the further like smart urban infrastructure, like as we are going towards the smart city development
So
factors.
the last question from my side. Are you trying to give some generic kind of solution?
Yes, ma'am, it's a
We have
generic.
actually studied a lot of papers for this, and we have identified like which solution would be the most apt one. So we are proposing that solution for now. Uh, like
But still, I do have
patterns
question
also.
of like for which system exactly you are proposing the solution. And when I'm asking you the question, you're telling me answer like smart city. But then smart city includes thousands of components. Smart city is not a single
Ma'am,
system.
This
basically
includes
Which
the
we are
health factors.
yes.
yeah, please.
This includes the health system. Particularly, if we focus on one factor of smart city, then it focuses on health system because it's like currently we don't have like devices or tools that could what should I say, that could perceive the future diseases that can be just like we had COVID. So in that we couldn't like predict like how much the loss would it be or how much damage would it done to the citizens. So this is kind of a model which could predict like the further diseases.
Okay, okay. You
And
can
ma'am,
please
like
continue.
this model that we have proposed, like we are going to work on it for our major project. Like we are going to code it. Like this will be our next paper.
Okay. Fine. Please proceed, please.
So shall we explain the layers or shall we proceed further only?
Uh,
Uh,
Actually, we have understood the concept and the problem statement. Do you have some literature survey done?
Yes, ma'am, literature survey was done. I could show you the references or the
Okay.
comparative analysis Tanvi would explain with the existing models.
So how did you present the literature survey? I would like to see the literature survey slide.
Ma'am, literature survey is not included in the presentation,
Not included. Okay,
but it's
okay,
there
fine.
in our research paper.
Okay,
we have tabulated it. Like it's in a table form.
okay. But then have you identified some parameters based on which you have performed the literature survey, or you have just listed the papers which you could go through?
No, no,
No,
no.
no,
In
ma'am. We
literature
actually
survey,
selected like few papers, and on that we worked on further. Like
Yeah.
like these papers we're going to continue like in the major project as well.
Okay, fine. ठीक है. Okay for
Okay,
me.
ma'am,
Yeah,
shall I continue with the comparative analysis?
yeah, please.
Okay. So when we compare USDT to current industry standards, our framework offers several key advantages. Traditional models rely on static or periodic data, whereas we provide continuous multi-model real-time monitoring. While centralized systems suffer from latency, our distributed edge cloud architecture ensures real-time scalability. Most existing models focus on a single data type, leading to incomplete insights. We fuse visuals, audio, and textual data for a comprehensive view. Most importantly, we shift from reactive analytics to predictive urban management using AI driven SEIR simulations, providing stakeholders with AR VR tools for dynamic scenario and exploration that 2D dashboards simply cannot match. Ananya, next slide. So the
security and
security
yes.
and privacy concern is that security is integrated into every layer of our design, not just as a parameter. We protect sensitive citizen health data using strong encryption and secure TLS channels for all edge to cloud transmissions to prevent man in the middle attacks, which is quite common. Because IoT sensors are prone to tampering, we utilize trusted boots and firmware verification to ensure device integrity. Furthermore, we address AI specific risks like data poisoning through adversarial training and model validation. By strictly following GDPR and HIPAA guidelines through federated learning and blockchain auditing, we ensure that our surveillance is both legally compliant and
Tanvi,
ethically
just a
safe.
minute.
Yeah, yes, ma'am.
So, are you using all these security solutions, blockchain and then data integrity
Ma'am,
from there?
like we will not use all these solutions. We'll select the one that will just suit the model the most.
So you have
Like
yet
these
not
are
picked.
just the options we are having for now.
Okay, okay, fine. ठीक है. You can come to conclusion.
Yeah. Ananya would like to go for conclusion.
Okay, so to conclude our UHDT framework, the zero trust architecture with multimodal AI to create a resilient disease aware smart city system. We have demonstrated that by leveraging edge cloud computing and federated learning, we can achieve a low latency processing and high fidelity forecasting while adhering to global privacy standards. So, by utilizing techniques like quantization and hardware acceleration, we ensure that these models can be reliable and the working is also fast, which can even be deployed on resources constrained edge devices. So, this framework provides the context aware and fault tolerant foundation needed for the further urban health or either urban infrastructures. So, ma'am, here are the references. Few of them are there, and rest are listed in the research paper.
Yeah, thank you, Ananya and Tanvi. I guess we can start with the
Thank
next
you, ma'am.
presentation,
Thank
Rajnati.
you so much, ma'am.
Okay, thank you, Ananya and Tanvi. You can kindly answer. Okay. So for the next presentation, I would like to call Anshika for the paper title Project O, where idea meets collaborators.
Hi, am I audible to you?
Yes, you're audible.
Okay, can I share my screen now?
Yes, you can share.
Okay. Is my screen visible?
Yes, it's visible.
Okay, so good afternoon, everyone. Hi, I'm Anshika Jain, and I would like to present my paper titled Projecto, where ideas meet collaboration. This paper is co-authored by Harshad Gupta, Rajesh Gaur, with the guide Dr. Arpana Mishra. This paper is basically based on a final year project of BTech. So first, starting with the problem statement and research motivation. Whenever we enter a college, we basically experience that the academic projects increasingly require collaboration within the institutional environments, where students from different domains work together on research and different innovative oriented tasks. So, however, the current practices rely on multiple disconnected tools for communication, networking, and collaboration. These tools operate independently and are not designed to work together within a college setting. So, as a result, collaboration becomes very fragmented, leading to poor coordination and challenges in forming efficient teams. So, moreover, the existing platforms lack a unified institutional level system for academic collaboration end to end. So basically, this work is motivated by the lack of unified platform within colleges that connects the student, peers, alumni, and mentors in a structured and a secure manner for collaboration. Moving on, based on the literature, we have identified few research gaps. First, these existing collaboration tools support only individual activities such as communication networking, but they do not focus on the complete academic project flow.
Secondly, institutional systems such as ERP, LMS basically focus on the administrative and instructional purposes rather than student-driven collaborative projects. Third, alumni and networking platforms enable professional connections, but they do not oversee the coordination of ongoing academic projects. Fourth, and most important, team formation in academic projects is largely manual and informal with limited intelligent and institutional verified matching systems. So finally, basically, the prior research studies these systems in isolation with a little focus on unified institutional level framework that integrates collaboration across academic projects. Now, based on the identified research gaps in the previous slide, we have main primarily three objectives. First, we aim to analyze the limitations of existing academic collaboration approaches within the institutional systems. Second, we seek to design a unified institutional level framework for academic collaboration and team formation. And thirdly, we aim to support the structured interaction among student, peers, alumni, and mentors within an academic setup. Correspondingly, the contributions for this work include a conceptual institutional centering collaboration framework, an integration model addressing collaboration, coordination, and team formation, and a framework formulation enabling intelligent and institutional verified collaboration matching. Moving on, this is a proposed system or architecture which we are currently developing the prototype of. The proposed system follows a layered architecture. The front layer provides responsive dashboards and user interactions using which the students and alumni can engage with the system. The service or API layer manages authentication, project handling, and
Anshika,
yes, ma'am.
just a minute. Which slides you are on? I
Uh,
mean, we are not being able to see the architecture diagram. Are you showing the diagram?
no, ma'am. I was showing the theoretical part.
Flip
Can you
side.
see the diagram? Yeah, this diagram is just to give an idea of what our architecture looks like. And the backend layer is basically implements the core business logic, and the AI NLP layer is still in the process, which will do the role extraction, skill analysis, and matching engine. And the database layer basically stores all the data like user profiles, project, etc. And we are also developing a real-time layer which uses socket.io to enable the live chat, notification, and feed updates. Now, coming on to the methodology, this is the overall methodology, but I'll take you through the different parts. So this slide basically illustrates the student project execution workflow. So how system works is student basically logins using the verified institutional credentials, that is basically your roll number and password, ensuring the secure and trusted access. Then you can, once authenticated, the users can create their profiles containing their skills, projects, etc. Now, students can then post their projects or research ideas on the platform, making them visible to all the people or the students of the institution. Now, what happens next is the system applies the AI-based role extraction to automatically identify the roles and the skills required. And based on this analysis, suitable collaborators would be suggested to you, but it is not necessary that you select them. You can also manually apply to collaborate in a project. Okay? Finally, the selected team members will collaborate that will support the cycle. Moving on, if I talk about the AI and NLP based role extraction, which is currently in the development, the project description, whatever the person posts, would be treated as a natural language input by the user. Then we will follow the standard text processing steps like tokenization, stop word removal, and lemmaization. Then the NLP model will be used to extract the roles and relevant technical skills from the project descriptions. And the project requirement and user profiles would be converted into vectors to enable the semantic comparisons. And further on, we'll use cost similarity, and the collaborators would be ranked based on the skill matching, experience, project similarity to get a weighted score. Then coming on to the alumni and mentor engagement flow, it would work somehow like the student workflow, where you will go in and log in through the institutional verification codes, and then you can write, alumni can post job, internship, and provide mentorship to the opportunities to the students. And you can also, go for one-on-one communication, which supports the mentorship and guidance. Talking about the results and declaration, basically these are our results. The result validates the feasibility of the proposed framework through the functional prototype. The system demonstrates a secure institutional access, centralized collaboration workflows, and structured alumni engagement. Now, workflow testing also confirms smooth interaction between students and alumni, while the AI-based matching and the other quantitative data is still in the process as a future enhancement. Coming on to the conclusion part, this study validates the feasibility of the unified institutional level framework for collaboration. The prototype also demonstrates the workflow fragmentation can be reduced using this, and it also ensures secure interaction among students and alumni. Uh, the results also indicate that the framework can modernize academic collaboration practices within the college. For future directions, we will first making sure that we integrate the AI and NLP's role extraction collaboration models, and secondly, convert it into mobile accessible interface. Also, making sure there are privacy preserving mechanisms and intelligent matching effectiveness. That is the future scope. These are some of the references that we have used since. And thank you so much. Do you have any questions?
Okay, thank you, Anshika. Ma'am, you can proceed with the questions.
No questions from my side.
Okay, thank you so much, ma'am.
Okay, ma'am. So for the next presentation, I would like to call Spooty for the paper title, Real-Time Indian Sign Language Gesture Recognition Using Deep Learning-Based Methods. I kindly request the presenter to start with the presentation.
Thank you, Nandini. Am I audible?
Yes, you're audible.
Okay, yes. I'll be sharing my screen.
Yes.
Is my screen visible?
Yes, it's visible.
Okay, yes. Okay, very good afternoon to one and all. I am Dr. Spooty Venkatesh from Adani University, and I am presenting my paper titled Real-Time Indian Sign Language Recognition, Gesture Recognition Using Deep Learning-Based Methods. And this work is my mentee's work, Sean Mane, and along with that, this is the collaboration work from NITK. So we have the co-authors are Dr. Rashmi Adyapadi and Professor Dr. Shashidhar G. Kulakuri. Coming to the contents, this is the brief of my presentation. I'll be introducing the topic. Followed by that, I'll be discussing the gaps we found in the research and the data set used, the proposed methodology. Followed by that, I'll be presenting the results, and I'll be concluding my presentation. So to introduce uh, the topic, gesture recognition has come up as one of the interesting and also much needed topic because in the global
Spooty, we
population
are
there are
not able to see your presentation.
uh, one second, I have shared it. Is it visible now?
No.
One second. Is it visible now?
Yes, it's visible now.
Yeah, okay. Rajnandini, is it visible now?
Yes, it's visible.
Okay, yeah, thank you so much. Okay. Around the world, we have found that based on the WHO research, that almost 5% of the people suffer from speech and hearing impairments. From this 5%, it has been observed that almost 80% of this group are semi-illiterate or illiterate group. In this work, we aim to provide a robust real-time system that will provide a Indian Sign Language gesture recognition to bridge the gap between the deaf community and the regular people for better communication. So here we focus on the vision-based, and this method can be a cost-effective method, and it can also be scaled for multiple devices. Based on the literature review, we have observed certain research gaps. Here in the current research, it has been observed that there are very limited vocabulary that exists for the Indian Language recognition system. So hardly there were some of the alphabets that we can recognize, that is from A to Z, or some of the digits, and there are 8 to 24 words which are actually used for gesture recognition. And it has also been observed that based on the background variations, there has been a degradation in the performance of the system as well. And here, sign language is a temporal mode based. The gesture is temporal based. So the current systems have used more of the spatial information. That is, it doesn't take in the information about the time of the gesture as well. And next, the last research gap which we identified was the need of larger vocabularies, that is more than certain classes where the communication can be smoother. Coming to the current research which we have performed, we have used the dataset include 50. So this dataset has 50 word classes, and this includes different categories such as adjectives and greetings. And this data was recorded from 7 different subjects. And also each signer, that is the each recorded person, has contributed to at least 2 to 6 videos. And the video length of each video ranges from 1.44 to 6.16 seconds, and it has been captured in the 25 frame per second. This is the block diagram which we have, which demonstrates the proposed methodology. So the proposed methodology can be divided into 2 sectors. One is the model development, and another one is the testing, that is how it reacts to the real-time data. So starting with the input here, as I mentioned in the previous slide, we have the input as include 50 data set. So in order to increase the model's trainability, we have augmented this data. And for the feature extraction part, we are using MediaPipe holistic key point detection method. I'll be discussing this in the further slide. Here in the real-time frame-wise feature extraction takes place, and the data has been stored in the NumPy arrays. Followed by that, the features have been split into, the data has been split into training and testing data split. And followed by that, in order to train the model, we have used a long short-term memory model. The reason for choosing this model is, as I mentioned in the previous slides, the temporal information is more important when it comes to the gesture recognition. So LSTM is found to be the right model, which captures the temporal information in a better manner as compared to the regular CNN models. Finally, after the training of this model, we have tried this method based on the real data, where the data has been fed through the webcam. And after the data has been recorded, the frame extraction takes place, and you can see the real-time gesture identified over the screen. So this is the methodology which has been explained. And coming to the actual feature extraction part, so MediaPipe holistic method is one of the state-of-the-art multi-pose estimation pipeline which has been developed by Google. So this model offers different type of landmarks, which includes face landmarks, hand landmarks, and body pose landmarks as well. So based on these key points, the different gesture or sign is being recognized frame-wise, and it captures even the temporal dynamics of these gestures as well. So as I mentioned, we tried to augment the data. So the reason for augmenting this data is to improve the generalization of the system and also to avoid the model to get overfit. So 2 methods have been used for data augmentation. Firstly, we have used central cropping, where the 60% of the frame content is being focused. And then another method used for data augmentation is horizontal flipping. So initially we had 958 videos, that is 20 per class. And in the augmented data set, we were able to get 3000 videos where we found 60 per class as the data set size. So coming to the architecture, here the long short-term model architecture has 9 layers. So we have introduced LSTM layers along with the dropout layers. So the reason for introducing the dropout layers is to avoid the overfitting of the model. So the dropout percentage which has been set is 0.2. And finally, to get the output, we have used the number of classes as the dense layer. And finally, we have the softmax activation function, which has been used to get the probabilities for the final classification.
Okay, ma'am, can we come to the conclusion? What conclusion you can draw out of your work?
Ma'am, I'll just present my results, and next slide will be my conclusion itself. Yeah, so these are the results and analysis part. So for analyzing our system, we have used 5 different metrics, and we have presented the results as before augmentation and after augmentation. So before the augmentation of the data, we found that the accuracy was 0.89, and after the augmentation of the data, due to more generalization, we found the results as 95%. And the only drawback was the training time increased, as obvious it is because of the dataset increase, the training time has also increased. And comparing the base paper result of this work, the Include 50 dataset base paper has a accuracy of 94. So compared to that, we have achieved a better performance after augmentation for our proposed method. So this is just an analysis of how the key points look. So based on this, as you can see, for each of the image, you can see at the top right corner, top left corner of the data that the gesture is also given up along with the key point detection as well. So here we have presented results for 3 such examples. One is for hello, thanks, and sick. So finally, to conclude my presentation, in this paper, we have presented a LSTM-based word level sign language recognition method, and we have achieved an accuracy of 95.3%. And here, along with the spatial characters, the model also captures the temporal dynamics of the sign language gestures. And here, the feature extraction is being done in real time as well. So this is not the end of the work. However, the current research only focuses on the word level recognition. However, for better communication, we would obviously need sentence or phrases to be decoded in the real time, and also it has to be accessible to the community as well. So this is the conclusion of the system. These are few of the references that have been used in this presentation. In the research paper, we have more references as well. So thank you, and I'm open for questions.
Okay, thank you, Spurti. Ma'am, you can continue with your questions.
Yeah. So have you used the existing data set or you're using real-time data?
Ma'am, this model was built on the existing system, but for the testing part, we have used the real-time data. So the results and analysis which we presented here, this is the data which has been recorded by my mentee.
Okay, so that is a
So
real
this is
data.
real time. Yes, this is the
Okay.
real time.
And how many records or attributes, how many data set, the records you have trained the model for?
Ma'am, the model was, the initial data set was given for, the original data set has 958. However, the augmented data has around 3000 videos, which has been trained, and there are 60 word classes.
Okay, okay,
Yes.
fine. Okay. So what
Yes,
is the
ma'am.
accuracy ultimately you got?
Ultimately, we found the result accuracy for this current system is 95.3%.
95. Okay, good. Okay, that's
Yes,
it from my side. Thank you.
yes. Thank you so much for giving me this opportunity. Thank you.
Okay, thank you, Spurti. So for the next presentation, I would like to call P. Chinnasamy for the paper title Skill Ladder, an intelligent career development system integrating resume analysis, learning and job management. I kindly request the presenter to start with the presentation. Here.
Am I audible?
Yes, you're
Thank you
audible.
for giving this opportunity. Thank you for giving this opportunity, Ms. Rajnandini.
Now I change screen.
Yes, you can share your screen.
It's horrible. It's showing. This is my project. Hello, my name is
Yes.
Mahendra. I am computer science engineer student from Kalasalingam Academy of Research and Education. Today I am here to present our project Skill Skill Ladder, an intelligent career development system integrating resume analysis and learning and job management. These are our teammates P. Shashank Satyaponsai, N. Hamid Reddy, M. Mahendra, K. Nagalinga. Our mentor is Dr. P. Chinnaswamy.
Sorry for the
Our
interruption,
published,
Mahendra, but can you please
uh,
complete your presentation within 6 to 5 minutes?
oh, okay.
Yeah.
This is our problem statement. Missing link between job portals and learning platforms. This means today job market there is a clear gap between learning platforms and job portals. Students gain skills, but they lack guidance on resume quality, ATS compatibility, and suitable job opportunities. For this, our objective is to create a uniform platform that streamlines the recruitment, career growth to ATS resume evaluation, application tracking, skill development, job posting, application management, and analytics. I will show you now our proposed model. This is our proposal model, developing a uniform platform with role-based desktops for job seekers and job providers, integrating ATS scoring and job recommendations to improve match and accuracy, providing a learning hubs with course, exams, and option coding practical for skill development, enable data driving hiring decisions with analytical dashboards, graphs, and applicant tracking tools. This is our proposal flow chart. First, this is start. Here we can log and sign up. Here we have two models for job seeker and job provider. In job seeker, access the job seeker dashboard. Here we upload our resume, performing ATS analysis score, viewing job recommendations for our ATS, and also for applying suitable jobs. Yes, jobs. I am audible.
Yes, you're audible.
Ba- based on the skills, the system here generates the personalized learning part. Job seeker can access, recommend courses, practice coding, and follow structural study plans. Progress is tracked on the dashboard. This ensures the continuous skill improvement and unlimited job requirement. Here we mock test. You can also create a mock test for the students who can learning for learning courses. Companies also can create mock tests. Job seekers can attempt this mock test to evaluate readiness. Performance data is also stored and used for analytics by recruiters. Now here job providers. In job providers, posting jobs on with required skills, tracking applicants, and monitoring risk scores, test results, and progress. These are the test stacks used in the front end. Here we use React.js and JavaScript. In the back end, we use Fast API, Unicorn, Python, Doherty, and PDF. This was used for the reading the data. We upload results by for in PDF format. For PDF format, we use the PDF2. These are our results, our website results. First, here skill ladder. This is the dashboard for the job seeker. First, we have dashboard here. Compatible score. We upload the resume. It gives the compatible score. Next, it also next in job recommendations also by selecting by using the analytic resume generator for generate the recommended jobs like here, and also it also provide the learning roadmap. Last, this is for the job providers. Here, job provider create the post new job, and it also employee dashboard. These are our references for our project. Thank you. Thank you for
Okay,
giving
thank
this
you, Mahendra.
opportunity. Do
Ma'am,
you
you
have any
can
doubts?
proceed with the questions.
So the only question I have is like, where do you find the application of your system?
We collect the data from our this project given by our guide, ma'am. Our guide guided us to do this project. He said us to there's so many separate apps for job application and for job learning. He said us why can't we integrate both systems? Our guide guided us to this project, ma'am.
Okay, fine, fine. So that's it from my side. Thank you.
Okay, ma'am.
Okay, thank you, Mahendra. Can you please unshare your presentation? Okay. So for the next presentation, I would like to call Ravin Kumar for the paper title, The Economics of Sovereignty, Faced Virtual Currency and Coalition Reserve Entity. I kindly request the presenters to start with the presentation.
Okay, is my screen visible?
Yes, it's visible.
Just one second. Okay, yeah, hi everyone. Myself Ravin Kumar, and I'm presenting the paper, The Economics of Sovereignty, Phased Virtual Currency, and Coalition Reserve Entity. So, what is the motivation and the problem statement? So, the global financial system is heavily currently concentrated in few dominant reserve currencies. For example, let's take United States dollar, that is USD. It's roughly the 58% of the global forex reserves are currently held in this currency. It's 2025 research and survey done by IMF. So, the concentration creates systematic risk, sanction exposure, spillover from the issuer's monetary policy. Small economics face reduced monetary sovereignty vulnerability to global liquidity cycles. For example, the country for in our so our paper is not targeting a particular currency, but because in 2025 2026 the target reserve currency of the dominant countries is USD, so the case study and everything is done with respect to United States dollar USD. So let's say US now decides to increase or decrease the supply of their USD. So it will have significant impact on smaller economies or smaller countries. For example, the countries which produce oil. So what we have proposed is a framework which enables a coalition of member. In our paper, we have proposed a case study for BRICS to reduce dependence on a target reserve currency. Target reserve currency here means USD, to preserve the macroeconomics and financial stability of the coalition during the transition. So basically, it means, let's say there is a group of countries which decide to get rid of USD, hypothetically. So our paper is what is the mathematical structure, or what can be the mathematical structure to dispose of the USD, assuming two scenarios. Scenario one is the when that dispose of is happening, one of the countries or multiple countries within the coalition can betray each other, because maybe when the dispose of starts or offloading starts, market was favoring the coalition, and when it was in process, it unfavored one of the country. Now, and the second thing is transparency. And obviously, there is one more part, which is during this process, we should not be creating another dominant currency. Basically, we should not be creating a currency which is more powerful than, let's say, USD. Otherwise, the other countries in the world will face the same issue, but instead of USD, it will be with some other dominant currency. So this is the whole idea of the framework, basically avoiding creating a permanent currency or ultimate authority in the world, and maintain flexibility and resilient cross-border settlement within the coalition. And while doing so, the economics of the coalition countries should not get impacted when they are de-dollarizing, let's say. So here is a proposed framework, which is basically we are proposing coalition reserve entity. Think of it like sort of an international bank, where each of the country, they will submit the target currency which they want to dispose of. In our case, let's say it is USD. So they will deposit it. Then the coalition reserve entity will issue in equal proportion some virtual currency which will be tied to blockchain. In our paper, we have suggested the usage of Ethereum because it inbuilt have smart contracts which are programmable by Solidity, which is like straightforward, and tech already exists for this. So, and after the offloading is done by the coalition reserve entity, and we have provided the mathematical formulation to do it so that there is no unnecessary uh, highs and lows in the economies of the nations within the coalition, and the settlement will happen. And at the time of settlement, whosoever holds the virtual currencies in that proportion, the assets gathered by the coalition reserve entity by selling, let's say in our case, dollars. For example, let's say all the three nations ABC, they deposit $1. Total $3 came to CRE. CRE will then buy some assets, let's say gold, silver, based on the current market situation. And when the complete disposal of 3 USD happens, then each of the country, whosoever holds the percentage of virtual currency issued by CRE, they will have that much ownership on the assets owned by the coalition reserve entity. Coalition reserve entity also have a marketplace which is optional so that the countries within the coalition can trade. For example, India requires steel and China supplies steel. So they don't need to transact in USD. They can directly do transaction. One question one may ask is, why can't we use CBDC, that is central bank digital currency? Now the answer to this is two part. One is the role of CRE is to get rid of the dominant currency, which is not the role of CBDCs. So basically, this is a mechanism, and system architecture, basically the steps are virtual currency issuance and redemption. Basically, it is issued, and the mechanism to redeem those virtual currencies to get the real assets. The mathematical equations for those are proposed in our paper. And asset management and portfolio optimization. So basically, when the CRE gets the money in USD, how will it mathematically invest such that it doesn't happen that when the dollar is crashing, the buying capacity of dollar is crashing, the assets that are held by the CRE also goes into loss. So to avoid that, we have proposed a portfolio optimization usage. So the equation already existed, but for different use case, but we are adding it here. Now let's go one by one. One is the Vichy issuance formula, that is how the virtual currency will be issued. So it is DI is, let's say nation I is deposit this particular currency in USD, and there are total these currencies multiplied by the total supply. This is the number of virtual currency which will be received by the nation I. So it is generally pegged. For example, one VC will be equal to 1 USD if USD is the target reserve currency which we want to dispose of. Now there is for the currency offloading part. Offloading means dumping. When the coalition reserve entity will dump the USD into the market and buy real assets, let's say gold, silver, oil. So this is a mathematical formulation for this: e to the power minus lambda t times 100, where the percentage denotes what is currently left in the reserve. So for example, at t equal to 0, it will be 100%. And with over a period of, let's say, 7 years, whatever the CRA decided and coded in the blockchain, the progress will happen. But as we know, the market rarely remains consistent across a time period. So we have also shared a multi-step exponential decay. So this is just one example. In this blue line, it's a single step decay with lambda equal to 0.25. In multi-step, it's a multi-step process happening after the interval of 2 years and 5 years. So as you can see, with the change in the market conditions, the group of coalition members can vote using the blockchain and can update the value of this lambda to decide on how much they want to deliquidate, or basically how much of the USD, let's say, they want to dump in the market and get the real assets. And this is the discrete formulation of the same thing. So basically, this is the same formula. What we have done is we have write it in a manner that if someone wants to do it every, let's say, 1 year, for example, 1 to 2, 2 to 3, that is also doable. So this is just a discrete representation of the same formula, but in multi-step format. And there is one more thing which is called velocity of virtual currency, which is basically if the money is getting used, money means the virtual currency is getting used in a quantity within the coalition. It signals that, hey, money might be required sooner, so let's deliquidate or let's dump the dollars faster and redeem it. But if it is kept at a particular place, or let's say the velocity is very low, it means the economies are self-sufficient we can increase the time horizon in which we want to deliquidate to look for a better option. And for the optimization, basically what to buy when we are deliquidating, we are using the Markowitz model of modern portfolio theory. It's a very standard model, although there are other models also which we have written in our paper, mentioned there, but this is the dominant one currently used. So it's basically like if the situation favors greater than or equal to our target, then sell or then buy basically. And just as a safety guard, the CRE, the coalition reserve entity, will have a buffer mechanism, which is generally kept at 5%. So in case of market volatility or let's say sanctions, the CRE will not require to take a loan or external help to run on its own, and it can behave fairly. So for the settlement equation, this is very standard like debit credit equations, where this is the exchange rate applied, and whosoever is redeeming the virtual currency, they can get the currency in their own currency.
Praveen,
Yes, ma'am.
sorry to disturb you. This seems excellent. Can you just go to the next slide?
Yes.
So
This
you
is
do
the
have all the expressions derived. So are these the expressions derived or the standard ones, the one which you are referring?
this one, the settlement equation is the standard equation.
Standard one, yeah.
Yeah, and these redeemed ones are the one that we have
Yeah.
built.
So this is your contribution, right? This you could derive.
Yes, the terminal redemption, buffer mechanism, and this decay rate equations. This is basically virtual currencies exist like Bitcoin, Ethereum, etc. Blockchain also exists, but mechanism to de-dollarize without affecting the coalition nations, that doesn't exist. So we have built a mathematical framework for it, and we have said like these mathematical equations can be used in the solidity or smart contract of Ethereum, and nations will have their representative, let's say bureaucrats, who will be operating this, and they will be able to decide on how fast or how slow they want to dump the let's say USD in the market, such that the entire dumping will be positive for them. It
So
shouldn't
this
affect.
this is kind of a innovative solution you have given.
Yes, ma'am.
Okay. So have you tried for patenting it?
No, actually, no, because in patents, mathematical equations cannot be patented.
But methods can be patented. I mean, you need to reframe it that way if possible.
Yes, I
In case
agree.
if you want to do it, there are ways to do it. I mean, you need to reframe it in terms of method or something else so that it will show the impact on. I don't know whether it will actually suit for your solution and the approach chosen. But then, if you show the impact of the some solution on hardware or some other stuff, say economy, probably it matters and they do consider it.
Okay, ma'am, I'll keep a note of it.
Yeah. Next slide.
Yeah. So the exit mechanism. So we have done a simulation study on BRICS. So let's say BRICS members deposit, let's say Brazil 10 billion, Russia 8 billion, India 6 billion, China 12, and South Africa 4 billion. And within a year of two span, the lambda 1 was 0.15, and Brazil and South Africa, let's say, decided to exit. So we have an exit mechanism. So exit mechanism in every year, the pegged values basically, one thing. So this is the graphical representation of the same thing. The dumping happened after the end of second year. Basically here, India and China bought it, and then they further decided to de-dollarize faster. They increased the value of lambda from 0.15 to 0.35, and then they lowered it to 0.25. So that's one of the case study we have done. And here the exit mechanisms we have provided, like the countries can hold either options, or they can sell within the coalition at the minimum reference price, which is regularly updated by the coalition reserve entity. And in our use case or in our simulation study, we use India and China as countries who absorb these of the auctioned value virtual currencies. Now there are two more slides. One is the CRE also provides optional marketplace, so that members can do trading, but it is not mandatory. Otherwise, it would be compromising on the sovereignty of the members, which will go against the paper. The second thing is external trade with non-members. So virtual currency can be used to do trade with another outside members also. For example, let's say India use virtual currency to buy oil from Iran. But there is one catch here. The catch is holding of virtual currency will not give you voting rights. Otherwise, it will have you can say it will become a loophole for the manipulation of the coalition. And the last and the very important part is when the dumping is completed and every country got the assets with the proportionality to the holding of the virtual currency, the CRE and the virtual currency must dissolve. Otherwise, it will eventually become something more powerful than the current target currency. One thing what we have not considered into our paper is also we have mentioned it. It's sanction routing, because it's obvious that the target currency which we are offloading the country will genuinely or generally they do sanctions. So that we have kept for as an open area because it's policy related, not like mathematics related currently. And these are the references we have used. So it contains study of IMF, some Swiss national banks, some papers about de-dollarization, financial studies, and the last one is basically usage of Bitcoin, Ethereum, and smart contracts. Yeah, thank you.
Okay, thank you, Ravi. Ma'am, you can proceed with the questions.
No, it's okay for me. I got the idea and the concept. It's okay for me. Thank you. I don't have any question. Good
Okay,
work.
ma'am. Now let's start with our last research paper. That's about Viranchi for the paper title IoT enables smart irrigation system. Can you
Hello,
present
am
now?
I audible right now?
Yes, you're audible.
Okay, let me share my screen.
Yes. And Milan, please try to complete your presentation within 5 minutes if possible.
Is that visible right now?
Yes, it's visible.
Hello.
Yes.
Milan, are you there still? I think there is Milan.
Am I
Hello.
audible right now, sir?
You are audible, but presentation is not started, I think. You just start the presentation.
Let me. Okay.
Your
Yeah,
PPT was visible.
it is visible. It is visible.
Okay. Now it's visible, right?
Yes.
Hi everyone. I'm Milan Baria from Nirma University. Today I am going to present research paper titled IoT enables smart irrigation system. My co-authors are Dhaval Shah and Viranchi Pandya. This is flow of my presentation. First, I will discuss introduction, literature survey, research contributions, proposed system, performance evaluation, and finally conclusion and future work. In a conventional irrigation system, water is supplied to crops according to fixed schedules. However, these systems do not consider real-time soil moisture conditions. As a result, problems such as over-irrigation and under-irrigation occur, leading to water wastage, higher energy consumption, and reduced crop productivity. Due to changing climate condition and irrigation water shortage, there is a strong need to adopt smart irrigation techniques to support sustainable agriculture. Before designing our system, we studied many existing research papers, projects related to smart irrigation and IoT based agriculture. Most of them Most of them previous work have used GSM based irrigation system, timer control based water supply, simple sensor based automation. In GSM based system, farmers receive SMS alert and control irrigation using mobile message. However, this this method is slow and costly. Timer based irrigation systems supply water at a fixed intervals, but they don't consider real time soil conditions, which results in watering or underwatering. Some systems use sensors, but they monitor only one parameter. Data is not stored in cloud and no remote monitoring facility. So our process system use Wi-Fi instead of GSM, provides real-time cloud monitoring, allow remote control through mobile app, reduce water wastage, and this survey helps and identify gaps, improve our system design. First of all,
Milan,
all,
would you please repeat the last sentence? Um, I have one question
yes, ma'am.
about. You
Yes,
said
ma'am.
the system uses some real time.
This system use real-time data from the field.
Okay. So have you considered the challenges which are there in using the real time data, and who will be the end user of this, solution?
End user will be the farmer.
So have you assumed and taken granted like the farmers with smartphones will use this solution? What is the investment cost for this?
Ma'am, actually, it's just prototype, not proper solution that can directly implement at the farm.
Yes, exactly. Prototype we use to design to represent our concept and idea, but then you can have the judgment of the cost of product from the prototype. Even you can just substitute the actual product cost at the prototype components, and then you can identify the cost. So if you are not analyzed, that's very much fine.
Madam, may I provide the answer for the same?
Please, please, sir, please.
Now, because it is IoT sensors, temperature, and more or less today farmers are having mobile phones with them, right? Many of
Okay.
the farmers are available.
Mhm.
ESP32 cost is it is not much, around 400 to 500 rupees. And
Okay.
different types of sensors are also available with the cost of 100 rupees or so. So
Mhm.
approximately cost for the unit will be approximately 700 to 800 rupees. And it
Okay.
can be, any farmer presently maybe
Can afford.
can afford. Yes.
Okay. So that is very much fine. I was just asking whether you have done such analysis, some rigorous analysis about the cost of product in point of view of selling it or making a product out of it or something else. And second question I had is like, yeah, have you tried to analyze the existing solutions, giving targeting the same problems?
Existing solution in the market presently, they are having phone mobile, government is having scheme for the same, but
Mm.
presently certain things are available with SMS, because certain krishi help are available, but they are using SMS for the same. Now here in this case the system can be automated using sensor mechanism, and
Correct.
automatically the motor will be on, and it can be, humidity can be increased in the soil, so that the system will work on its own, like this.
Mhm.
Proposed system is like that.
Okay, sir. Okay.
Ah, okay.
Milan, you can please continue.
Okay, so let me go with this line. We propose an IoT-enabled smart irrigation system to offer real-time monitoring of environmental parameters and supply water to crops when it's required. And we integrated Node MCU with DAT11 temperature, humidity, and soil moisture sensor, which will collect the real-time information from the soil. We also use Wi-Fi technology for transmitting the real-time data to cloud server and Blink mobile application. In this real-time data helps user to control their irrigation system remotely. The performance of proposed system is evaluated using various parameters such as real-time variation of humidity, time, and soil moisture. Here is our proposed system. As we can see, processing unit, sensing unit, and actuation unit, and also we have a user interaction unit. So in sensing unit, we put sensors, soil moisture sensor and DAT11 sensor, which will measure the temperature and humidity. So here we have a proposed algorithm. In that we can see that when the soil is dry or the level of humidity is beyond the threshold, then this ESP32 will be notified to the actuator motor, and it will.
it is very much understandable. It's clearly mentioned, है ना? So algorithm is very much giving you the idea of like it is for algorithm for smart irrigation system. Yeah, you can please go to the algorithm. Correct. I guess you have taken a screenshot of your paper, research paper, and then kept it over here.
Yes, ma'am.
Okay, fine. You can go to next slide. Not an issue. This is understandable. This is
Okay, and
experimental
here is
setting.
the
But
equipment
ideally,
setup.
I feel like just a minute. Listen to me. Ideally, I feel like experimental setup should be mentioned as the configuration of hardware and software used. The experimental
Mm-hmm.
setup should be drawn symbolically to indicate the components of your system, and then this will be the actual like photo of your setup. It is not experimental setup. Experimental setup should be depicted with standard symbols and method you should use. The
Okay,
problem
ma'am.
over here is we can understand
Mm-hmm.
you have configured it very nicely. You have actually created designed the PCB and not PCB, that breadboard you have used, and you try to make connections. Go to that slide. But
Yes,
there,
ma'am.
here the connections are not clear. Are you getting me? Here the connections are
Okay,
not.
ma'am.
We can see there are some colored lines, colored wires, and they are connected from here to there and so on. But we are not being able to check which wire is connected to which component. So you should use some standard symbols to depict the individual
Mm-hmm.
components of the setup, and then establish and show the connections, whether it is unidirectional, bidirectional,
Mm-hmm.
or it is just a single line or a bus or something else.
Okay.
है ना? So
Sure,
that
sure,
makes the
madam. Thank
concept
you.
clear.
Yes, yes. Thank you for your
Yeah.
valuable suggestions. We will surely update, I mean, if possible.
Yeah, sir. Because this is okay. I can understand you have taken efforts and you are trying to show it. I do appreciate, but then showing it in standard way will make the things more clear, right?
Yes, yes.
Okay,
Yeah.
ma'am.
Yeah. Thank you. Next slide.
Yeah, so here is a graph performance evaluation. Here in first graph, we can see manual irrigation and smart irrigation,
Okay.
where we have day number versus water used. So if we use manual irrigation, we required more water as compared to in
Okay.
smart
Correct.
irrigation system.
Correct. And
And
can you
in
brief about the second graph? What the second graph
it's
is about?
it's about moisture versus time. So it's change when weather change. Like in morning, it has more moisture, but at afternoon it will go down. So it
So this graph
change.
is about, yeah, this graph is like for deciding, it is the deciding component for your system to work, right? It has
Yes, ma'am.
nothing to do with the performance of the system. Correct?
Yes,
Yeah.
ma'am.
Go to the next slide.
Here it's a graph of temperature and humidity sensor. So we also set a threshold at if it's less than 45 humidity, we can start our motor, and if it goes beyond a maximum temperature like
Threshold you have
for
set.
more than 40
Okay.
Celsius, it will
Okay.
start.
Okay. Okay, next slide. This is
Yeah,
okay.
so yeah, conclusion and future work.
So what is your conclusion out of this work?
So in this research, we successfully developed an IoT-enabled smart irrigation system and
Mm-hmm.
real-time monitoring. Our system provides real-time monitoring, and
Mm-hmm.
it also automatic irrigation control, remote
Mm-hmm.
access through mobile application Blink, and
Mm-hmm.
reduce water wastage and improve irrigation efficiency.
Okay, ठीक है.
Yes, ma'am.
Okay.
And these are the references we have used.
Mm-hmm.
Yes, ma'am. Yeah.
Yeah, seems okay. I hope you will incorporate the discussion points, the points which we have discussed in your further research and presentation.
Yes,
So as
Sure,
yes,
to
ma'am.
sure,
Sure.
sure,
what
ma'am.
is-
We will update that.
yeah, yeah. Thank you, sir. Thank you.
Thank you for your suggestions.
Thank you, sir.
Okay, thank you, Milan. Now I'd like to go with the closure of the session. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during this 10th version and all the previous 9 version of the conference. We will be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificate through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Professor Sheetal Nayan Girme, for chairing the session. A token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Would you like to address the participant, ma'am?
Um, Actually, we had the real-time discussion during paper presentation only, and that's what I believe in. I don't believe in going through the paper and then collecting the questions and then asking them to the participants. It's better to clear the concepts at the and the problems and the questions at the same time. So I hope I mean, inputs and suggestions given to participants would be incorporated. Those are for like their future betterment and the future presentations to make more impressive, inclusive, and yeah, all the best to all the participant, and everyone have done good job. We wish all the best to all of them. Thank you.
Thank you, ma'am, for your valuable words. Now I request every participant to switch on the camera for a quick virtual snapshot. Okay, thank you everyone for your participation.